Hello team, in this lesson we start review of the first category of the OWASP Top 10. We are going to discuss today broken access link category. We'll start from learning of what an access control is. When we will learn what access control is, you will be able to understand what broken access control is, and you will be able to understand potential impact. After that, we are going to review different vulnerabilities that are associated with this risk category. All vulnerabilities will be reviewed based on the code examples. I will share with you our online store that we developed together with my students from scratch during the course Java from Zero to First Job, and on examples of online store, we'll understand potential impact that might be caused by vulnerabilities, and we'll fix them. Also, on real examples, I'm going to show you design solutions that is recommended to follow to make your application more secure. During the lesson, we are going to review such vulnerabilities as insecure ID vulnerability, path traversal vulnerability, client caching vulnerability, violation of the principle of least privilege, elevation of privilege. This is going to be a very interesting lesson. Let's get it started. I already did a high-level overview of this risk category in the first lesson, but let me go deep now and explain you more about this risk category. The category is called broken access control. Let's learn first, what is an access control? In a nutshell, access control represents a set of policies and mechanisms that manage and control access to resources. Access control is also commonly known as authorization. Once the server has determined your identity through a login or authentication mechanism, it grants or limits what functions and resources you have access to. This may be implemented with the help of the roles mechanism. Together with my students of my course Java from Zero to First Job, we already implemented online store and we used roles mechanism in order to set access restrictions. Today, during the practical activity, I am going to show you this too. Another way to manage access is to use security token, like in OAuth or in JWT. What is OAuth and JWT? This is a broader topic to discuss, but let me explain you very briefly to not miss context. OAuth stands for Open Authorization. It is an open standard for access delegation, commonly used as a way for Internet users to grant websites or applications access to their information on other websites, but without giving them the passwords. For example, login with Google button or login with Facebook button is example of OAuth. JWT stands for JSON Web Token. It is a proposed Internet standard for creating data with optional signature and/or optional encryption whose payload holds JSON that asserts some number of claims. The tokens are signed either using a private secret or public-private key. For example, a server cloud generated token that has the claim logged in as administrator and provides it to a client. The client could then use that token to prove that it is logged in as admin. The tokens can be signed by one party's private key, usually the server's, so that party can subsequently verify the token is legitimate. If other party is in possession of the corresponding public key, they too are able to verify the token's legitimacy. So, to summarize definition of access control, we can say that access control is the implementation of constraints that control who can perform actions, and which actions in particular can be performed, or access resources that they have requested. In the context of web applications, access control is dependent on the authentication and session management. Authentication identifies the user and confirms that they are who they say they are. Session management identifies which subsequent HTTP requests are being made by that same user. Access control determines whether the user is allowed to carry out the action that they are attempting to perform. I assume that based on what we have discussed, you already can understand the next two terms. There are authentication and authorization. What is the difference between these two terms? Authentication basically identifies who you are. Authorization is about verifying whether you have enough rights to perform an action or to access a resource. Imagine that you are at the airport and boarding on your flight is started. You need to prove your identity, that you are the person with the name on your ticket, and confirm that with your ID card or passport. And once you confirmed who you are, you will be able to take your place according to the ticket, enjoy the VIP meal if it's specified in your ticket. In case you are not authorized to enjoy VIP meal, you will not be provided with it. In the digital world, authentication and authorization accomplish these same goals. Authentication is used to verify that users really are who they represent themselves to be. Once this has been confirmed, authorization is then used to grant the user permission to access different levels of information and perform specific functions, depending on the rules established for different types of users. There are different types of access control. They are vertical access controls, horizontal access controls, context-dependent access controls. Let's learn a little bit closer each of mentioned categories. Vertical access controls are mechanisms that restrict access to sensitive functionality that is not available to other types of users. With vertical access controls, different types of users have access to different application functions. For example, an administrator might be able to modify or delete any user's account, while an ordinary user has no access to these actions. Horizontal access controls are mechanisms that restrict access to resources to the users who are specifically allowed to access those resources. With horizontal access controls, different users have access to a subset of resources of the same type. For example, a banking application will allow a user to view transactions and make payments from their own accounts, but not the accounts of any other user. Context-dependent access controls restrict access to functionality and resources based upon the state of the application or the user's interaction with it. Context-dependent access controls prevent a user performing actions in the wrong order. For example, a retail website might prevent users from modifying the contents of their shopping cart after they have made payment. At the first glance, you might be wondering, and what may go wrong with access control? Is it really so hard to configure roles or tokens, or just to control access to resources? This shouldn't be so hard. Despite the simplicity of its concept, it is not so easy to implement a robust and secure access control system. Access control is closely bound to the system architecture. Moreover, users regularly fall into more than one role, which makes access management more complex. Therefore, developing access control from scratch is generally discouraged, and battle-tested, robust solutions like OAuth 2.0 is adopted instead. Okay, so now we learned what an access control is. But what is broken access control? Broken access control comprises a set of known exploits that can represent a threat to your system's access control. Despite many of the vulnerabilities in access control being easily exploited when neglected, they can be addressed relatively quickly. This point is important because the consequences of a breach in access control can be pretty destructive, since attackers can take over your system. Let's summarize the impact that can be caused by vulnerabilities from this category. The technical impact is attackers acting as users or administrators, or users using privileged functions, or creating, accessing, updating, or deleting every record. So, basically, once access is gained, attackers can perform operations with data and systems they need. it is hard to quantify the specific impact because there can be different levels of access to different parts of the system, and impact can vary. Obviously, there are a lot of different broken access control vulnerabilities. They depend on the technology stack you use and your software architecture. Let me show you examples of some common vulnerabilities of the broken access control. First of all, I recommend you to download the web application, our online store that I've mentioned at the beginning of the lesson. This is important because I'm going to show you examples based on our web application. You will be able to find also solutions and a lot of source code examples here. Let me start from the insecure ID vulnerability. Imagine that we have user profile page. My web server is up and running already, so I open web browser to see the user profile page. Pay attention to the URL. I send request to the user profile URL and I pass query parameter ID. Obviously, this is user ID. You might be wondering, and what is wrong with this? In most cases, using ID to access resource might be okay. For example, there is no critical harm in big impact in accessing product page by its ID, since it doesn't store any sensitive data. But still, we're going to come back to this case a little bit later. Let me show you the product page. I type product in URL, and again, I pass ID query parameter. That seems to be fine, but you should take into account that in case attacker will identify the name of the resource, in other words some URL, and will learn list of required parameters, attacker can use brute force technique to extract all the data. And in case with user, we can access personal information, emails that will be used for spam in the future, or will be used in attempts to hack the account, information about amount of money on the account, and so on. What is brute force? With the brute force attack, an attacker submitting many different values or passphrases with the hope of eventually guessing correctly. Basically, you can create a script or program with any programming language that will open the page with different ID attributes, will parse the content on the page, and will store somewhere this data. This is not good, and this can be treated as a serious vulnerability. Let me open the source code of the servlet that handles this request. I open user profile servlet. Few words about project structure. All examples related to the OWASP course I will store in the OWASP package, and in the sub-packages associated with this risk category. In some particular cases, examples may be stored in actual solution. In this case, BAC subpackage name stands for Broken Access Control. And inside we are going to have problem and solution packages. In problem package, we are going to store source code that describes problem statement, and in solution, source code that contains solution to the suggested problem statement. That's how easy you can find all related code examples. Here you can see that I get ID parameter and I use user facade to extract the user and put it in the request scope. I also perform other operations here like extracting of user referrals and preparing partner link and so on. The main thing here is that there is no active control in place to validate my request. I can access any profile. How to solve this? There might be different solutions, but in this particular case, I would validate the incoming request and would show only that information that the user is allowed to see. How to do this? If you want to access your profile, then please log in the system, let me validate your credentials, and only after that, server will show you information you requested. And this information will be related only to your account, because you are not allowed to see other accounts. Let me show it to you. In the URL, I type profile, and what do I get? I'm redirected to the login page, because application need to verify my credentials before showing me information. I enter login and password, and now I can access my profile. And pay attention, there is no ID in the URL, because server decides which information I allowed to see and which information I can't access. Do you understand? Let's look at the implementation. I open Profile Servlet. The first check that I do here, I check whether there is some user in the session that is already provided his or her credentials. In case there is no user object in the session, we redirect user to the login page. And in case there is a user in the session, we extract all latest information about profile from the persistent storage, and we forward request to the presentation again. In this case, it is not possible to access the user which is not stored in the session. And just to remind you that we put user in the session right after successful login. Here in the sign-in servlet, in the row number 42. Is that clear? Team, in case you have any questions, please do not hesitate to ask your questions below this video and I will be happy to answer. Let's proceed with the next example. Another solution is to use GUID instead of ID. What is GUID? A GUID stands for Globally Unique Identifier. It is 128-bit text string that represents an identification, ID. Organizations generate GUIDs when a unique reference number is needed to identify information on a computer or network. Using GUID will not allow attacker just to increment ID number to navigate through the website in the automatic manner. For example, in our online store, attacker can implement script that will open each product page, will parse the page, and this information will be used to impact our business. Let's imagine that daily our competitors check the price in our online shop with the automated scripts, and after that, the same automated scripts update their selling prices in order to win competition. Or any other examples. Having GUID generated significantly reduces chances to guess the product GUID, because there are much more symbols. Thus, parsing all the data from the site just by URL parameters tampering becomes close to impossible. Let me show you example. In my database, I added GUID field to the product table. I also added GUID in my default product type, and I created new controller that is called PDP Servlet. Let me find it in the solution sub-package near other examples. Here it is. I get GUID parameter from the request and extract product by its GUID. The rest of the code is similar here to our previous example in existing solution when we extracted product by its ID. I put product into the request object and forward request to the view following my MVC pattern. Let me open the browser now. In our browser, I change URL address to access PDP resource and I pass GUID of the first product. I took it from the database. User can navigate to the product page from the product listing page. We need also to change GSP pages on PLP. But I believe you already understood the solution. Look at this GUID. It is less likely that attacker would use brute force to guess GUID. That's it. That's all what I wanted to share with you regarding insecure ID vulnerability. Let's move on. The next vulnerability that I am going to explain is a past traversal vulnerability. What is it? It is also known as a directory traversal. It is a web security vulnerability that allows an attacker to read arbitrary files on the server that is running an application. This might include application code and data, credentials for backend systems, and sensitive operating system files. In some cases, an attacker might be able to write to arbitrary files on the server, allowing them to modify application data or behavior, and ultimately take full control of the server. A system without proper access control might be a victim of past traversal exploits and allow attackers to access restricted resources in the server. This situation can happen when the path of a resource the system is allowing to retrieve is accessible to be modified and is not adequately validated. To illustrate this, let's imagine that we have a controller that can return the pictures on request. Let me show you in browser. I type in URL getPic and pass query parameter that is called name. This is the name of the pic that I want to retrieve. I wrote flag PNG. And as you can see, I have image from my web server returned. And again, at the first glance, probably you don't see any harm in this. But let me show you something interesting. What if I would adjust parameter in the way that will allow me to navigate over the tree of the file system on the server side? For example, I would type /webinf secrets secret.txt. And again, team, this is just an example. We can have different variations of the same vulnerability and the same problem. When I show you one example, try to analyze all the similar cases you can think of. The main idea here is that you have possibility to pass the input to the server. And when you can pass input, there is always a risk that you can pass different inputs to find vulnerabilities on the server side. As you can see in the browser, I have just received access to the content of the secret file. This file may contain information about secrets and passwords to other systems and services, whatever. This is not okay, and the attacker can use this information to break your system further. Let's investigate how it is possible. You can see in the URL that I accessed file inside webinf folder, but you remember that resources in the webinf Java web application folder are not accessible outside of the server. And you are right, resources are not accessible outside of the server. But I sent file name to the server, and on the server side I found requested file and sent it back. You can't access directly webinf folder via URL and its content too, but you can access it on the server side. Can you understand this? In my servlet, you can see that we parse the query parameter, and using images prefixes, we create a path to the resource. But be aware that using of the prefix doesn't make your solution more secure. Do not forget that knowing the path that I need, or again using the brute force, I can navigate up and down in the directory list. The parameter that I passed in the URL, 2 dots, basically allows me to navigate on the one level up, and from there I can access another folder that is called webinf and secrets, and then I can open file from that directory that I need. Is that clear? Let's think now what we can do to fix this. First of all, you always have to understand how the underlying operating system will handle file names passed to it. Well, the first solution, the easiest one and the most reliable one, do not allow user to pass user inputs when it is not necessary. Even if you think that it would be great to allow a client to pass value here to the server, don't do that without thinking and making a wise decision, because all user inputs may be used by attackers. Avoid user input whenever is possible. Another solution might be a validation of user input. You can think that you will validate slashes and double dots in the parameter, and that would be it. But again, I can name at least few options how to bypass validation. For example, let's imagine that you implemented validation to check slashes and dots. Okay, good try. What you will do when I will pass such kind of parameter using URL encoding? Just look here. Having URL like this, I also can access secret file. What we'll try to do next? We'll implement another validation for person sign. I love these games and I can play them forever. Just joking. I can even try to use not relative but absolute path to get access to the file on the server's operating system. Easy. Probably you want to make validation of the file extension to be retrieved, and you want to validate that parameter will end up with .png extension. Well, okay, but I can use so-called poison null bytes attack. What is this? A null byte represented as /0. It is an encoded character that is usually not visible and is used only for encoding purposes. This will be already harder, but still possible on some servers. This exploit can be used against a web server that truncates the request at the null byte, such as Microsoft WIS and Netscape Enterprise Web Service. But there are different variations how to bypass this too. Let's talk about other solutions. The third solution is to configure file permissions. We should properly configure file permissions and even to restrict, read, and edit access for the critical files. We can use some solutions provided by cloud providers to manage sensitive data. For example, Azure, AWS, and Google Cloud provides secured and proven solutions for secrets management. The fourth solution is to make application validate the user input before processing it. Ideally, the validation should compare against a whitelist of permitted values. We can use Safelisting to validate user input. What is Safelisting? Safelisting consists of creating a list of possible paths that can be accessed safely. Safelisting is a simple and comparatively effective approach to reduce the potential for exploits. By adding this validation to user inputs, you can have an extra layer of protection against malicious attacks. Let me show it to you. In the solution folder, I have getPictureServlet. Let me open it. I create a list of strings. This will be my safe list. This is a list of image names. All images that are available in my images folder. Definitely, you can store this not in memory in collection. You can also store it outside of the source code. It's up to you how you will implement this. But the main thing is that I have some list with all valid file names of my images. In my servlet, I initialize this list with values. I have separate method here. Feel free to explore it later. If you are a student of my Java course, please refer to the section about input and output streams. I covered there how to work with path object. In short, I get path object of my images folder. After that, I convert it to file in order to get access to the sub-elements in this directory. And I created function that adds file name of each file from images folder into our collection. And in our servlet, I add validation. I allow access to the resource only in case path parameter is present in my collection with file names. Otherwise, I print text that image with such name doesn't exist. Let me open browser and show you examples. Basically, I will just change the URL. I will add -solution word to get big URL. And you can see I can't access secret file anymore, but I can access flag.png because this file name is present in my safe list. Isn't this cool? The fifth solution. In case implementation of safe listing is not possible, then the validation should verify that the input contains only permitted content, such as purely alphanumeric characters. Now you have a solution how to avoid such vulnerability as path traversal vulnerability. Let's review another vulnerability. I'm going to explain now client caching vulnerability. Imagine that you are in a cafe and you logged into our web application. After that you was distracted or you just went to the restroom and you left your PC on a table. Somebody accessed your PC while you were in the restroom and made some orders from your account using your balance on the account. This is a scenario of client caching vulnerability. Client caching vulnerabilities are tough to address because they involve attackers physically taking over the user's computer. Instead of remote attacks, they take advantage of the session credentials, cached pages, or data in the browser already present in an authenticated client. Once this happens, the attacker can quickly gain access to the user data. In this case, the most effective solution is also the most simple one. You can shorten user session. If you noticed, in bank applications usually there is very short session, and in case screen remains inactive for some period of time, session is invalidated. Additional recommendation may be to validate user credentials on performing critical operations. For example, in some applications when you perform critical operations, there is either email verification or SMS verification or password verification. We can implement it in the way that when I change password, I am asked to enter old password first to confirm my action. Or when I make money transaction, I should confirm this behavior with a code from SMS. Let me show you an example. So imagine I left my laptop and I logged in my account. Somebody entered my profile in order to change information. For example, to change user email or to change password. And you can see that to be able to update user and click update button, I need to enter password. And I don't know password. Let me type any password because as an attacker, I try to remember how password looked like. And in case I changed email, entered some invalid password, and just click update button, I see error message telling me that I need to enter current password to confirm the action. That's it. Let's talk about the next vulnerability. The next vulnerability that I'd like to discuss is a violation of the principle of least privilege or deny by default, where access should only be granted for particular capabilities, roles, or users, but is available to anyone. In our application, we already implemented web filters that helps us to avoid mentioned violation. In the filters package, you can find admin and management filters. They verify role of the user before granting access to the resource. Let me open the web browser and show it to you. We have a page with list of all orders. On that page, we change fulfillment status of the order. As you can see, I can't access it via direct link. I am redirected to the sign in page. Let me sign in with a test user. After I successfully logged in, let me try to access that page one more time. And I see 403 forbidden error. I am not allowed to access this resource. We should follow the principle deny by default and grant access only to those resources which should be available for the user based on the role. Except for public resources, deny by default. That's how rule sounds. All users that were registered through the sign-up form automatically assigned to the customer role. So all users of my application has roles, and access is controlled. Let me sign out, and I will sign in with management account. And when I want to access orders page, I can see it now. Because in my filter, I verify the role of the logged in user, and in case role is role manager, then I allow access to the resource. Never forget about this. There are different frameworks that can help you to improve authentication mechanism in the application. Spring Security exists for Java. Spring Security topic lies outside of the scope of this lesson, but stay tuned. In my Java course, we will review it in a separate lesson. There is also another similar vulnerability, not the same, but similar. Elevation of privilege. It describes a scenario when we can act as a user of the app without being logged in, or acting as an admin when logged in as a user. And the last thing that I wanted to cover is a comparison of this risk category with the same risk category from the OWASP Top 10 2017. I can say that this category in general, in its description, sense, and others remained unchanged. So not so much things to compare. That's all what I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson we learned what access control is, and what broken access control means. We reviewed some vulnerabilities and possible design solutions to avoid these vulnerabilities. Among vulnerabilities we reviewed, it is worth to mention insecure ID vulnerability, past traversal vulnerability, client caching vulnerability, violation of the principle of least privilege, together with elevation of privilege. And after this lesson, you also have an answer how to prevent such vulnerabilities. That's it. Thanks a lot for your attention. Have a great day and see you in the next lesson.